Hey everybody, the purpose of this video is to give you some solutions to the normal distribution review quiz that we had up for this past week. It had to do with drivers in Portland on I-5. We got an average speed of 71 and a standard deviation in those speeds of 8. And I'm assuming that that data is, we're calling them parameters, we're calling you 71 and sigma 8 based off probably tens of thousands, if not hundreds of thousands of observations, which, as we talked about in class, shrinks your margin of error down so small that essentially you don't have one anymore. So anyway, we'll treat them as parametric values. So in each of these curves, you're going to have that average of 71. I've written up 4 curves because we have 4 problems to attack. So, and we'll deal with the 8 as we go as well. The first one says, what percentage of vehicles are exceeding the speed limit? Because according to my data source, the speed limit was 65. So 65 miles per hour is down here somewhere. Okay, so anybody going faster than 65 is exceeding. So these are all the cars that are exceeding that speed limit. Now we know that a standard deviation of 8 down from 71 is going to be 63. So we're within 1 standard deviation down. So at this point, you've got a couple different ways you can knock this bad boy out. Probably the easiest way is to convert these things to z-scores so that your average is standard normal 0. So since you're 6 down from 71, you're 3/4 of the way down from 71. So you're going to end up with a negative 3/4 z-score down this way. In case that's not making sense or not ringing a bell to you, your z-score formula is whatever your raw data is minus your average over your sigma. So since x in this case is 65 and mu is 71, 65 minus 71 is negative 6 over 8, negative 3/4. So this guy's going to be negative 3/4. So essentially, rather than plugging these guys into a table or a calculator, you want to plug this guy. If you had me for 243, I gave you a program called Stanormal that takes care of that for you. If you didn't have me, you still have the program, so you can always ask me how to use it. So anyway, I ran it, and I ended up getting a percentage. Let's get some lines here. I ended up getting a percentage of 77%. Correlating to that. So you've got 3/4 of the cars are speeding, which is, do with it what you will. Based on this data, that's what's going to happen. 77%. I shouldn't say speeding, they're exceeding the speed limit. Now whether or not that's considered speeding is up for discussion. So anyway, that's there's your solution to the first one, 77%. Let's take a look at the next one. What percentage are traveling within 2 miles an hour of the speed limit? Okay, 2 miles an hour, so let's do this in blue, shall we? Speed limit again is 65 miles an hour. So that means within 2, I'm going to draw this a little bit, not to scale, just to make it visible. That means we can be going as low as 63, as high as 67, or anywhere in between. And again, the key is to get z-scores for these bad boys. So you want to change the 63 to a z-score. That z-score, since it's exactly 8 down from 71, that guy's z-score is going to be a -1 because it's 1 standard deviation down. So that z-score is -1, and this z-score, since it's only half a standard deviation down, is -1/2. So these are your 2 z-scores right here, -1 and -1/2, and you want to figure out what area is between those 2 z-scores. Now you might remember from 243 that -1 to +1 is 68%. It might be tempting to say, okay, there's 68%, that means this is 34%. That means this has to be half of that at 17%, but that doesn't work that way because the 2 areas aren't equal when you split the z-scores in half. This area comes out to be 20%. 20% is this guy right here. So 20% is your area between -1 and -1/2, giving you your percentage of those within 2. Now, why you would need to know that, I'm not sure. I made that one up because it figured, why not? Let's do a between problem. So far so good. 77%, 20%. I'm rounding these off to, I think, the nearest whole percentage, so do with it as you will. Driver can be cited for unsafe speed for either operating a vehicle more than 9 under. It seems like a strange way to phrase that, and I apologize if that's confusing. More than 9 miles an hour under. So 71 is your average speed. 65. Oops! I just realized I did this problem. I cranked the numbers wrong. We can write it right up here. I'll get you guys started. So the speed limit is 65. More than 9 under would be down all the way down to, what would that be? Well, 55 would be 9 under. So 56 would be a cutoff for that one. So anybody going this slow, 56 or slower, is going to be more than 9 under. And more than 10 over is 65 up to 75, which is going to be this guy up here. So then all you've got to do is figure out the z-scores corresponding to these guys. So this is 4 up from 71. 4 up from 71 is a half a standard deviation. That's a positive 1/2. Okay. And then 56, let's see, how far down is 56 from 71? That's 15, isn't it? Yeah, that's 15 down. So 15 down is almost 2 standard deviations. I've drawn it kind of poorly. It's almost 2 standard deviations down. 15 would be 1 7/8, right? 1 7/8. So that's going to be a -1 and to 2. Well, you can go to 3 decimals, I guess. 7/8 is 0.875, so it's -1.875. Now, what I can do is you can do you can use the normal for sure and find the area between this one and this one, and then just subtract it from 1, which allow me to do that very quickly. I ran the wrong numbers before. It's a problem between -1.875 and positive 0.5, and that's going to end up being 66% here. So this area is 66%. That means these two areas have to be the other 33. So you got about a 33% chance of either exceeding that way, or I hate to call it exceeding, maybe de-seeding. We'll make up a new word, de-seeding. So you've got de-seeding here and exceeding here. I guess that kind of makes sense. Cool. Okay. And then last but not least, we've looked at all these numbers and we realize, oh my lord, you've got 77% exceeding the speed limit. You've got only 1 in 5 between 2 miles an hour between around the speed limit. It seems like maybe we need to redo the speed limit. It's not 65 isn't working, and they're averaging 71. Let's have only 15% exceed it. I want no more than 15% to exceed it. So this becomes a backwards problem. Assuming that changing the speed limit won't change the average speed, which is I don't think it's a fair assumption. I think it might change the average speed. But let's just assume that it stays the same for the time being. It might take a while to change it. We want to put the speed limit up here versus down here. Down here, the majority are speeding. If we put it up here, the minority are going to be speeding. And what minority do we want? Well, we only want 15% to be exceeding it. Okay, that's what we want. So the question is, what should we make it so that is the case? Now, what you're going to have to do is figure out, just like we did with everything else, we're going to have to make that an average of 0, and the question is, what is this as a z-score? Now, 15%, again, I'm going to do this a little bit punk rock, not so much using the technology for the sake of technology. We know that within 1 standard deviation, you've got 68% of the data, ish, 2/3, 68%, whatever you want to call it. 68%, which means 32% is in the tails. If that's the case, that means you've got 16 and 16. That means this is darn close to cutting off 1 standard deviation on this end, which is pretty slick actually. So if you need more precision than that, that's when you run to technology. I cranked it and it ended up being 1.04, which is a little bit further right, which means that's a little bit less than 16, which makes perfect sense. Anyway, that z is 1.04, which tells you the number of standard deviations out. Then what you have to do is reverse engineer this back into the curve to make sure that you can actually get a meaningful speed limit out of that. So since your z-score formula was up there, we're gonna reconfigure that thing, z sigma plus mu, to give us our raw score. And And then we know these three things. We know that we're about 1.04 standard deviations. The standard deviation right now is 8, and the average speed was 71. That's about 8, right? It's 8-ish, I'm going to call that 8. And that's 71, so make it 79 miles an hour. 79 miles an hour will ensure that no more than 15% of cars are speeding. Of course, you run the risk, number one, that's a pretty fast speed limit. I mean, you might want to bump it to 75 and keep with, say, Idaho's speed limit. Also, you run the risk, if you raise the speed limit, you might also raise the average speed, because if people are going 71 averaging 56, there could be a linear relationship there. Maybe it's 50 or 65 implies 71, maybe, you know, 79 will imply 85, although I don't think that's the case. A few years ago, it's been a while now, Montana had a stretch of road where they just allowed, it was no speed limit at all, like the Autobahn in Germany. And I believe, I remember reading or hearing that when they did that, people, the biggest concern was people are going to drive 100 miles an hour down the road. And I'm sure that a few people did, but on average, they weren't going much above 80, I don't think. It's been a while, I don't remember exactly. But you can't just assume that because you take the speed limit away, everybody's going to go speeding down there as fast as they can, because, you know, think about when you leave Oregon into Idaho and the speed limit jumps to 75 miles an hour. You probably will start getting a little bit nervous in places where, you know, you're like, oh my, the car's shaking in ways it's never shaken before. I'm a little nervous about that. So anyway, getting sidetracked. Here's some solutions for you guys. 79 miles an hour, 33%, 20%, 77%. Hope that helped.